Hey there, my name is Harry Kalodner. I'm one of the co-founders of Off-Chain Labs, and Off-Chain Labs being the original creators of Arbitrum, and here, excited to be here today to talk a little bit about Arbitrum, a little about like the history, how it works, and then kind of what's next and what the exciting things we're working on are. So very excited to be here. So just kind of very high level to start off. Hopefully most of you are kind of already familiar with Arbitrum, but for anybody who's not, we are an optimistic rollup, a layer 2 solution for scaling Ethereum, where we have essentially what feels like a separate blockchain with its own capacity, but tightly connected with Ethereum, easily securely transferring funds, providing low-cost transactions in a way that's secured by Ethereum with full EVM equivalency. And so kind of anybody used to using Ethereum or using any EVM chain, you can go on Arbitrum, you can take advantage of our ecosystem, of the like amazing UX that kind of the chain has for anybody who's used it. And generally, it's a great place to be. And so just a few numbers there for people interested. Arbitrum right now has a very large percentage of the overall share of kind of users using rollups for kind of real world usage today. Over $5 billion in value in the system. I think this is still accurate. Around 65% of kind of the total usage of rollups is in Arbitrum. And over 1,000 dApps and huge number of unique addresses. So kind of if you're looking for a chain with like a very large ecosystem and with kind of very tight Ethereum alignment, Arbitrum is the place to be. And just to kind of go into a little history, just because this is really interesting and I think generally surprises people kind of how long this has been going on for. The original idea behind Arbitrum started back in 2014 by one of my co-founders. Before Ethereum had actually even launched, seeing the problems that kind of if Ethereum ever reached real mass adoption, that the bandwidth available wouldn't be enough for kind of anywhere near what would be needed. And already at that point kind of thinking about what would be necessary. Now the project then kind of petered out a little bit. It was very early. Ethereum had barely launched. Back in 2018, we kind of started back in earnest and kind of progressively built up until August 2021 when the actual chain launched. And Arbitrum 1 opened up as an optimistic rollup that anybody could deploy on, anybody could use. And then since then, we've kept iterating. And so again, 1 year later, we actually threw out the entire tech stack. We launched Arbitrum Nitro, which was a huge iteration on the technology and basically replacing large percentages of what we had built. And providing even kind of faster speeds, cheaper transactions, and kind of continuing to constantly iterate, which is something we really believe in. Nothing that anybody's building today is going to be the best in class in 5 years. All of us have to keep innovating in order to really keep up with the ecosystem. And then on here, we also have kind of the other really big milestone that was very exciting, kind of that happened earlier this year, which is that the Arbitrum DAO launched, and Arbitrum 1 and Arbitrum Nova became decentralized chains that are community owned, which was a huge milestone. And from there, the growth will only continue. And so I just marked on here a couple big upcoming things that we're very excited about. One being permissionless validation. That will lead to kind of the essentially the pretty full decentralization of Arbitrum in a very real way, and kind of the goal being to continue the iterative decentralizations that rollups have been experiencing over the last couple of years, and to really reach that kind of targeted, essentially end state, and kind of fulfill the promise of what Ethereum's building towards. And the other, in a very different area that we're extremely excited about, that I'll talk a little bit more about later, is Arbitrum Stylus. Which is going to massively extend the capabilities of Arbitrum technology by also enabling smart contracts using WebAssembly, so programming in C or Rust or C++, which is going to massively open up what's possible in the blockchain space. So I'm going to just kind of start in and talk a little bit about like high level, what is Arbitrum other than kind of a chain that you can connect to on your RPC. And the best way to describe that is to talk about how sequencing works on Arbitrum, because that is kind of the life cycle of what's actually happening when you submit your transaction. And so there's an entity called the sequencer that all transactions get sent towards. The sequencer will then order those transactions. And so that essentially defines kind of what the outcome of the chain is, because what a chain is a bunch of transactions that are executed in the order. Each one updates the state, and so then you have your blockchain. But how does it actually get secure? Because what I could just describe could be a server on AWS. And what we want is a real decentralized, secure system. And so what the sequencer does with those transactions, well, two things happen then. on the right-hand side of this, you can see those transactions go through the state transition function. We build blocks. Those blocks have effects. It could be swaps. It could be deposits or withdrawals, any number of things. Those create L2 blocks, much like what a regular blockchain would look like. The other part is what's unique to rollups, where we see this part which is batch and compress. And what's happening there is this really great thing that rollups do, which is actually posting those transactions to Ethereum. Which is the main method by which that, along with part of the protocol mentioned later, inherit the security from Ethereum, which is paid for by every user when they use Arbitrum. So that's kind of the high level of what happens to your transaction. And the other cool part about sort of how the technology works is this is not a completely separate tech stack from Ethereum. This is not like some other random system. This is building on top of Go Ethereum, which is the core and most used Ethereum execution layer client. And so what that looks like is that Arbitrum starts with its core and just builds on top of it. It extends it slightly, it modifies it in various ways, but it lets you take advantage of all of the tooling and all of the ecosystem that's built around Ethereum in a very fundamental way. The way you become Ethereum equivalent is by actually having the same engine that drives Ethereum be at the core of your equivalent system. And so the next part that's really interesting here, and this is kind of one of the big innovations with Nitro that we launched a year ago, is separating execution from proving. And so we essentially have two different paths that the same code takes. On one side, we have the core state transition that we compile into WebAssembly, and actually are able to prove on chain. But that wouldn't be very efficient if all the system was running this locally, because it wouldn't be native speed quite the same way as you would hope with Ethereum. So then you would have less capacity on your rollup than you have on Ethereum, which would not be good for anybody. And so the trick here is that instead we also compile that same code to native code for your machine. And if we had two different executables, if we had two different systems that were supposed to be identical, there would be a huge amount of risk here, because we'd have two implementations, we'd have to make them be perfectly in sync, it wouldn't work. But instead, you can take the same code and just compile it in two different ways, and you can have this high level of confidence. And then the last part, which I'm not going to go into because we're pretty short on time, is the actual optimistic rollup mechanism. And this is the mechanism by which the chain is at any validator can actually challenge the correctness of an assertion. You're never, when you use Arbitrum, trusting the sequencer once a transaction's been posted to the chain. Once a batch has been posted, the result is, and you may have heard of this 7-day window, and there is a 7-day window for challenges, but everybody locally knows after a batch has been posted what the outcome is, and it's guaranteed to happen. The only thing that the window is for is to actually prove to Ethereum that that actually is the correct state. Everybody else is a lot faster than Ethereum, and this is kind of the core point of an optimistic rollup protocol, is that we're going to do stuff off-chain, and because Ethereum isn't powerful enough to process all of the transactions on Arbitrum along with everything it's already doing, and so we have this lighter weight and longer protocol to actually convince Ethereum that our state is correct. And then I'll just mention Arbitrum AnyTrust. Which is a solution that's kind of built on top of, and I just kind of display it here as a small addition to the diagram I showed earlier, which moves the data off-chain. Since everything I described before is a rollup, where the data is actually posted to Ethereum, whereas Arbitrum AnyTrust is what we call our solution that uses an external data availability source. And so what that means is you take the most expensive part of running a rollup, which is actually paying for Ethereum security for the data posting to Ethereum, and you instead have a separate committee that's responsible for that. And the cool thing here is it's not like it's not like a side chain where you need to still, let's say, assume that 2/3 of some group are honest in order for your chain to be secure. Because here, you only need 1 or 2 out of the entire committee to be honest in order for the solution to function. And so this is a really cool sort of intermediate point where where rollups are still too expensive. For DeFi, 30-cent transactions are amazing, but for gaming, 30-cent transactions might be insanely expensive. And so kind of exploring solutions on the spectrum of decentralization with the trade-offs involved is really powerful for kind of finding product market fit for different solutions. So now I'm going to take a little time to basically give some quick highlights for what's coming next. I've talked a lot about kind of where we are today, but we're busy. So we're by no means sitting still at where we are. So I'll talk about kind of 3 quick areas that I think are of a lot of interest right now. The first being sequencing and MEV. From the beginning, Arbitrum had a solution that we called first come, first serve, which is sort of about transaction ordering. And it's a system that works well, but has a lot of issues in terms of, for instance, if people are familiar with backrunning and latency races. And it creates a lot of sort of opportunities where the competition to capture arbitrage value isn't exactly fair. And so one of the things that we're working on here is, and it's the second one on here that we call time boost, is for selling off that ordering and actually having a much more fair market. Decentralized sequencing very much in here as well, being that right now there are various kind of especially short-term trust assumptions. Before the sequencer has posted a batch, right now if you wanted to call your transaction secure, you're just trusting the sequencer, whereas decentralizing this mechanism more can provide higher security levels faster on the chain before batches have been posted. And finally, shared sequencing, where in this world where we're exploring kind of more and more and more chains, there's this really interesting question of what sorts of infrastructure can be shared between multiple different chains and what advantages different chains can get from having that shared infrastructure. And so these are all kind of really interesting areas. Next up, we have what I mentioned at the beginning, Arbitrum Stylus, which we'll be talking a lot more about soon, which we've already kind of talked about some. And this is the ability to actually run smart contracts using WASM, which we're incredibly excited about. It's an extension, we call it EVM+, because it's not replacing the EVM. What it's doing is it's providing a completely second VM that can enable all sorts of use cases that just aren't possible on Ethereum today. Because the EVM is great in a lot of ways, but it's also very limited. And we think that sort of extending it and providing new capabilities is a really powerful paradigm. And then the last one I'll mention is Arbitrum Orbit, which is our system for launching layer 3 blockchains using Arbitrum technology. And this is really kind of an interesting area just because it takes the sort of already well-known, well-studied secure technology that you have for Arbitrum today, for Arbitrum 1 and Arbitrum Nova, and you extend that to actually support anybody to launch their own chain as a layer 3. And that's kind of, from there, it's really sort of a situation where the sky is the limit, and I'm really excited to see what people do. Since the code is extremely modular, extremely pluggable, there's a huge amount that you can do by taking this existing code and modifying it in different ways. For one fun example being adopting new EIPs that aren't supported on Ethereum yet and wouldn't be supported in something EVM equivalent. But you may not care about EVM equivalents. You may instead care about having, for example, native account abstraction. Gas price reliability, not fighting for block space with other protocols. And then cheaper bridging, if you're bridging into Arbitrum 1, that's a lot cheaper than bridging from Ethereum. And so having that interoperability between L2s and L3s is a lot more flexible. And to leave room for a few questions, I think I will wrap it up there, and thank you very much for listening.
Hi there. It was a really good talk and I enjoyed it quite a bit. I think like the era of public blockchains we're living in now is like the L2 wars. So kind of as someone who's building a dApp, it's a really hellish period to be in, because what happens if the L2 we are on just like goes belly up or gets like rugged or just stops existing? So kind of that was one question of like, how do we do that? And the second is the super chain, whether there's an equivalent of what Carl Flosch talked about, the super chain, whether there's an equivalent going on at your side.
Yeah. So I mean, to the first question, I mean, and this is like, I'm obviously very biased here, so I can't really be impartial. But I would say that like looking at, the two factors to really look at when looking at choosing a chain, one is ecosystem. So who else is there? What kind of value is there? What kind of users are there? And the other is decentralization and security. And I think Arbitrum plays really well on both of those. I would highly recommend L2 Beat as a resource for anybody interested in the security of these systems, which does a great job, given that kind of the complexities involved in actually understanding this are pretty deep, and it requires a lot of kind of deep investigation, and a lot of times protocols aren't exactly excited to talk about kind of the security risks involved, and L2 Beat is impartial and does a really good job there. In terms of kind of like the super chain or hyper chain, there's a lot of, I think, like a lot of the different L2s. I think hyper chain is zk sync, if I remember correctly. Super chain optimism. It's definitely an area we're interested in. I think that to me, kind of it's very early. And I think that it's kind of, for my comfort, it's a little too early to kind of commit to like one model for these new systems. And kind of we've always had a very research-driven approach. So I think it will come, but I'm dubious that kind of people who are sort of saying this is the end state, this is the dream goal today, are necessarily gonna still feel the same way in a year or two. And I want to make sure that we take the time, and it shouldn't be a year or two to be clear, but I want to make sure we take the time to get it right.